Good afternoon, everyone, and welcome to our webinar. If you were to experience any technical issues, you can raise them to reach us via the chat. And if you have any questions that you want our presenter to answer, you can use the Q&A channel for that, because then other participants will see those questions and be able to upvote them if they want similar info. We will go through the question and answers session at the end of the webinar. So good afternoon, everyone, and today we will be talking about the access and use of Sentinel-3 data. My name is Jurgen Everaerts, and today I have the pleasure to introduce Carolien Toté. She is a bioengineer from the KU Leuven. She joined VITO in 2009 in the remote sensing applications team. She's currently working on the validation of remote sensing products. Carolien is a member of the Sentinel-3 Optical Mission Performance Cluster, the Sentinel-3 Quality Working Group, and the Sentinel-3 Next Generation Mission Advisory Group. So, Carolien, the floor is yours.
Thank you, Jurgen, for the introduction. So welcome again to this webinar on the access and use of Sentinel-3 data products on Terrascope. As an introduction, I would like to shortly touch on the subject, what is Terrascope? So Terrascope is a collaborative ground segment for the Copernicus Sentinel missions. The project is funded by the Belgian Science Policy and has as a main goal to make satellite data easily accessible for a wide range of users. So Terrascope focuses on data dissemination and access by redistributing Sentinel core products and complementary products, and by providing tools and applications to users. Apart from the products from the Sentinel constellation, Terrascope also distributes products from PROBA-V and SPOT-VGT. So what are the satellite data and products that are available on Terrascope? So these are the products derived from the Sentinels. Sentinel-1 is a synthetic aperture radar imager. We have products available for the area around Belgium. There is Sentinel-2, a high-resolution optical sensor. We have data for Europe and parts of Africa. And then there is global data from Sentinel-3, on which I will focus in this webinar, and Sentinel-5P, which is dedicated to monitoring the atmosphere. And also the archives, as I said before, of PROBA-V and SPOT-VGT products are available on Terrascope. Other products on Terrascope include a global digital elevation model, the global land cover maps at 10-meter resolution from world cover, and Sentinel-1 and Sentinel-2 yearly composite maps, the world serial crop map of 2021. There is global vegetation indicators from the Copernicus Global Land System that are currently also derived from Sentinel-3. There is local high-resolution imagery and much more. But as I said before, I want to focus in this webinar on the access and use of Sentinel-3 data products on Terrascope. So I will start with providing some background information on the Sentinel-3 mission objectives, what are the instruments on board the Sentinel-3 satellites, product families, and so on. And then I will go in more detail into the SPOT-VGT-like products. Why is this done, and what are these products, and what is the quality of these products? Next, I will show more details on the land surface temperature products and product quality. And then there is a section on the product access, focusing on the Terrascope viewer, product download, virtual machines, and OpenEO. And finally, we will shortly look at the near and farther future in the What's Next section. I want to warn you, please stay ready to respond to some poll questions that will pop up in the webinar. So first, some background and details on the Sentinel-3 mission. So the objective of the Sentinel-3 mission is to measure sea surface topography, sea and land surface temperature, and ocean and land surface color with a high accuracy and reliability to support many operational systems. So the Sentinel-3 mission is jointly operated by ESA and EUMETSAT, where ESA is mostly focused on the land products and applications, and EUMETSAT on ocean products and applications. Sentinel-3A was launched in February 2016, and after 2 years in orbit, Sentinel-3B was launched in February 2018. And during the first 6 months of the Sentinel-3B mission, both satellites A and B were positioned in a close tandem formation. So both A and B observed the same place on Earth within 30 seconds difference and with the same viewing geometry. So this tandem phase helps to accurately intercalibrate and harmonize the instruments on both satellites. So if you are interested, you can find more information and links to publications on this website. It has there are some interesting information on the lessons learned from this tandem phase. So the end of the tandem phase was in November 2018. So since then, Sentinel-3 A and B are in their nominal orbits. There are 4 main instruments on the Sentinel-3 satellites. The first one is OLSI, the Ocean and Land Color Instrument. It's a push broom imager. So it's tilted a bit westwards to mitigate the negative effects of sun glint over water surfaces. So it's specifically designed actually for ocean color measurements. It's a medium resolution sensor at 300-meter resolution at nadir, and it has 21 spectral bands in the visible and near infrared. Then there is the SLSTR. It's a sea and land surface temperature instrument. It's a conical scanning imager with a dual view technique. So one instrument has a nadir view, the other one looks oblique backwards. And the SLSTR measures the temperature of the Earth's surface at a spatial resolution of 500 meters for the visible near infrared and shortwave infrared channels, and at 1 kilometer for the thermal infrared channels. It includes also 2 channels for monitoring wildfires specifically. The simultaneous acquisition of OLSI and SLSTR facilitate the use of both acquisitions in synergy, like is done for the SPOT-VGT-like products. Then there is the ESRAL. It's a synthetic aperture radar altimeter. It does not have a SWAT like OLSI or SLSTR. It's not really an imager. Instead, it receives single measurements every time a pulse is emitted. And this is the main topographic instrument on Sentinel-3. It measures sea surface height, ocean waves, sea ice extent, the height of large inland rivers and lakes, and so on. Then there is the MWIR, or the microwave radiometer. This one measures brightness temperatures, water vapor, cloud water content, thermal radiation, and so on. And it's actually used to correct the measurements of the ESRAL sensor because it's affected by water vapor in the atmosphere. So the combination of ESRAL and MWIR are used for topographic measurements of the ocean and inland waters. But in the rest of the webinar, I will focus on specific products derived from OLSI and SLSTR. So this is an animation of Sentinel-3 in space. Here you see the SLSTR instruments with the nadir viewing scanner and the oblique one. Here in front is the OLSI imager, where the light comes in is here. At the back you have the ESRAL, and here in the middle you have a series of instruments for precise orbit determination and antennas for communication with the satellite, and important for, of course, the data downlink. Then on the Sentinel-3 products, so first on level 1, these are the top of atmosphere radiances that are geolocated and resampled, both for OLSI and SLSTR. For ALSI, they are available at full resolution and at reduced resolution. And for SLSTR, there's also the surface, the brightness temperatures available. For the surface topography mission, there's a series of level 1A and level 1B products available, but I won't focus on these. At level 2, from ALSI, there is a series of land products. The green instantaneous FA-PAR, fraction of absorbed photosynthetically active radiation. There is the OTCI, a terrestrial chlorophyll index. And you have a long list of ocean and atmosphere products like water relieving reflectance, algal concentration, total suspended matter, and so on. For SLSTR, there are two basic level 2 products, that's sea surface temperature and land surface temperature. You have also synergy products. So these combine measurements from the ALSI and SLSTR sensors. You have the first, the main synergy product is the land surface reflectances of all ALSI and SLSTR channels. There is an aerosol product. And then you have the VGT-like product. So there is a VGTP-like product. It's combined VGT-like top of atmosphere reflectances. And there is a VGT-S-like products. These are the synthesis products at 1 day and 10 day composite periods of surface reflectances and the NDVI. So here goes the first poll. You can launch it. So the question is, have you used Sentinel-3 core products before? And if so, which ones? So the level 1 products, ALSI level 2 products, SLSTR level 2 products, or one of the synergy products, or maybe one of the topography products. Let's see. The answers are coming in. I see most of you have used either level 1 products or level 2 products from ALSI and SLSTR, but I don't see any users of the SYN products. Maybe let's wait a few seconds more. No, it seems that we don't have synergy users. Let's see, maybe after this webinar, you're interested in looking into those. So as I said before, I want to focus on the land surface temperature products and first on the VGT-like products, the so-called SYN VGT products. So first, why is this done? So it's a product continuity for the SPOT-VGT mission. So the SYN VGT products from Sentinel-3 are designed to provide surface vegetation products similar to those obtained by the SPOT-VGT instrument on board on SPOT. So SPOT-VGT was monitoring the planet from 1998 till 2014 with almost daily global coverage. And it delivered surface reflectances and NDVI from the ground segment. So it was used for a wide range of applications. So the current available collection is collection 3. It's on Terrascope. PROBA-V was developed as a follow-up of the SPOT-VGT mission and as a gap filler between SPOT-VGT and Sentinel-3. So the PROBA-V channels are very similar to those on SPOT-VGT. PROBA-V collection 2 was released to the public last year. So the Sentinel-3 SYN VGT products, which are these, they are provided on a regular grid. They consist of a top of atmosphere product, which is a VGP product. It's segments. It contains also a status map, information on cloud shadows, and so on. It has also angular information on the time of acquisition, and some atmospheric parameters. The VG1 and V10 products are maximum NDVI value composites. So the NDVI, or normalized difference vegetation index, is calculated from the red and near infrared bands and gives a measure of the amount of vegetation. And it is used in this context to select the best observation for each day in the VG1 product and for each 10-day period in the V10 product. So these VG1 and V10 provide surface reflectance measurements and the NDVI. Surface reflectance is in 4 spectral bands, also a status map and some ancillary information. How are these products generated? So this is a general overview of the processing workflow. The starting point is the collocated observations from ALSI and SLSTR. Next, what is done is a spectral band mapping. So here you see for the 4 bands of SPOT-VGT or PROBA-V, the blue, red, near-infrared, and shortwave infrared, you see an overlap of the PROBA-V spectral response function with those of ALSI and in this case SLSTR. So in the spectral band mapping, this information from ALSI and SLSTR is combined to match the PROBA-V or SPOT-VGT channels. Then there is pixel flagging, so classification of pixels as land, water, cloud, snow, and so on. And there is projection to a regular lat-long grid. At this point, the VGP products are outputted. Next, there is the atmospheric correction and the compositing step, and this yields the daily and 10-daily composite products. So these SYN VGT products are disseminated as such for VGP. These are full single orbit segments, so pole-to-pole segments. You see here an example of one of these files. So in these file names, you have the start of acquisition, end of acquisition. That are these first 2 timestamps. The third timestamp is the timestamp of the processing. This is the duration of the segment. It's almost, I think it's 44 minutes, something like that, from North Pole to South Pole, and some indication on the orbits. The VG1 and V10 products are provided as tiles. So you see here a map of the 10 tiles in which these products are provided. And these products have a time step that starts 0 UTC until midnight for the VG1 and also for the V10. You see here in this example, the V10 composite from the 21st of January till the end of the month. So the idea of this 10-daily composite is to provide 3 composites per month. The first one from day 1 to 10, the second one from day 11 to 20, and the third one is day 21 till the end of the month. There are three composites per month. These products are provided in non-time critical mode. So it means that the requirement is to provide these products up to 1 month after acquisition, but typically they are available in about 3 days after the end of the compositing period. So there is more on product access later on in the webinar. So this poll, I think, Jurgen, you can launch it, but I don't know if we get much answers because, so the question is, what SYN VGT products are you interested in? I've seen you have not used them before. That was in the previous poll, but let's see if you are interested in using some of these. I see some interest in the daily and 10-daily composite products. That's nice. So mostly in the 10-daily composites. Okay, that's good to know. So the 10-daily composite is the most important ones to those that are interested in SYN VGT products. Then I want to show a few slides on SYN VGT product quality, because this is very important for users that combine these products with SPOT-VGT or PROBA-V data products, or users that want to use the time series of these products. So it's a continuous evolution. During the SYN VGT data availability, the processing, there was a series of updates to the processing baseline that have gradually improved the content of the product. So I've listed the most important updates here. In September 21, there was a correction in the product gridding. In June 2020, there was an alignment of the temporal compositing scheme. So it was an alignment to what was done in SPOT-VGT and PROBA-V, and also an alignment between Sentinel-3A and Sentinel-3B. In June 21, there was a correction in the definition of the VG1 and V10 NDVI. So before that date, these NDVIs were based on top of atmosphere reflectances instead of top of canopy reflectances. It was corrected. In the summer of 2020, there was improved handling of saturated values, and there was a very important update in July 23. So what they did then, they corrected the spectral band mapping. So before that date, they used the spectral response functions from SPOT-VGT 1, the first SPOT-VGT, to do the spectral band mapping. They switched to using the PROBA-V ones because this is a more logical step from PROBA-V to Sentinel-3. They also applied calibration adjustment factors for SLSTR. So from vicarious calibration, they now know that the SLSTR sensor measures too dark signals in some of the channels. So this was a difference of 11% for the S5 channel, which is the most important one in this case. From the tandem phase between Sentinel-3A and Sentinel-3B, they got calibration adjustments for ALSI-A. So ALSI-A is a bit too bright compared to ALSI-B. So they adjusted this calibration with 2% for most bands. And then finally, they discovered a bug in the spectral band mapping procedure, and this was fixed. So I will show in the next slide the impact of this change. If you are interested in knowing more about product quality, I advise you to look at the publications of the Optical Mission Performance Cluster. So this OPT-MPC monitors the instrument performances and the calibration and validation of the products. So every time there is a new release of a product, there is a product notice with details on what has changed in the processing. Every month there is a data quality report, and every year there is an annual performance report with a more in-depth validation of all products at all levels of Sentinel-3. So more on this last change in the processing baseline, and well, what is most important to users of SYN VGT probably is the consistency with the archives of SPOT-VGT and PROBA-V. So what I did here is a comparison between the Sentinel-3A products of January till June 23 with on the y-axis the PROBA-V collection 2 long-term statistics, or the average over 5 years, 2014 till 2018. For the 4 spectral bands and for the NDVI. So what is clear is that for the shortwave infrared band, there is a large systematic bias. So these measures here, accuracy, precision, and uncertainty. Well, the uncertainty gives a measure of the scatter. Of course, there is quite some scatter because, first of all, we are comparing different periods, the year 23 with the climatology of some years ago. There is also the angular configuration that is different and is not corrected for, so this also has an effect. So this explains the scatter and the uncertainty. But for now, we are more interested in this average bias or accuracy. And you see it's very large for the SWIR bands, quite large also for the red bands. And this results in a considerable bias for the NDVI. After the last processing baseline update, you see a big improvement for the shortwave infrared bands, thanks to these, mostly, I think, thanks to the bug fix, but also the calibration adjustment and so on. And also the red band has improved. So this leads to a better consistency for the NDVI, which is a widely used product from PROBA-V, SPOT-VGT, and also SYN VGT. So there is better agreement for the higher NDVIs, but still there is a systematic bias for the lower NDVI. So we are not there yet to get a really good consistency at this point. This one also shows this. So in order to look at the consistency over time, we compare to a reference time series, in this case from MODIS. So we generate a combined series from SPOT-VGT 2 from 2009 till 2013, for PROBA-V from 14 till June 2020, and then the last few years are based on Sentinel-3 This plot is a Hofmöller plot, so it shows the accuracy or the average bias, the evolution over the years and for different latitude bands. And well, first of all, we don't expect to see a zero bias everywhere because there are some intrinsic differences between MODIS and the SPOT-VGT, PROBA-V, and SYN VGT products, because the spectral bands are different, the processing is different, and so on. But what we would like to see is a stable evolution over time. And of course, we also see a small jump at the switch from SPOT-VGT to PROBA-V, but it's not as big as compared to the switch to Sentinel-3 at mid-2020. You see a very big bias in the first year and a half, let's say, because then the NDVI was simply wrongly calculated based on wrong reflectances. And gradually the bias diminishes, and in the last months it seems to look okay. So there is a large improvement towards the end of the time series, but we need some more time to evaluate the temporal consistency after this last processing update. And of course, it's clear that there is no consistency over the entire time series. So we've seen in the past years large improvements in this SYN VGT product quality over the years, which leads to better consistency with the archives of SPOT-VGT and PROBA-V. But currently, we don't have a consistent SYN VGT archive. And I'm not so happy to say that currently no reprocessing is planned, which is a pity, of course. Apart from this, some quality issues remain to be solved or to be investigated more in detail. So there is still an inconsistency of the NDVI product, as I've shown before. Also, what I did not show, there are some artifacts introduced by the atmospheric correction in the SYN VGT processing line, mostly because the aerosol load is overestimated. What we also see that's from the start and from the design, the Sentinel-3 and Sentinel-3 SYN VGT products are currently not combined in one composite product. It would be helpful to do that because then you get a better completeness, less cloud contamination and so on. So it's something we could look into. Also, what I did not show, there is an omission of clouds. So some clouds are not detected as such. And currently there is no cloud shadow detection. So my next question, the third poll, is on this SYN VGT product quality. Which aspects of the product quality are more or most important to you? Is it the consistency with the SPOT-VGT or PROBA-V archives? is a temporal consistency over the entire SYN VGT time series, which means that archive reprocessing is necessary. Are these the artifacts by atmosphere correction, the need for combined Sentinel-3 A and B products? Also, I've put here the global stitched products instead of the continental tiles. You need better cloud screening, better cloud shadow screening, or none of these. Let's see. Yeah, I see the temporal consistency over the entire SYN VGT time series is important. That's also my feeling, that this is something that needs to be done in the future. I also see some interest in the combined Sentinel-3 A and B products. That's currently not foreseen in the ground segment, but I hope that at some point they will look into this, or we at Terrascope might look into providing this product. Okay. Thanks a lot for your answers. Next is a section on land surface temperature, LST. So land surface temperature, it's a measure of how hot or cold the surface of the Earth would feel if you touch it. So it's the mean radiative temperature of all objects that are viewed by the sensor. So it's trees, rocks, bare ground, built-up areas, whatever. And it's based on the thermal channels at 11 and 12 micrometer on the SLSTR sensor. So what is also used as input is a series of ancillary layers. So the biome, fractional vegetation cover, water vapor, and these inputs are used to define a series of regression equations. It's called a split window two-channel approach. Then there's also pixel flagging, and this generates the level 2 LST product as such. So these standard level 2 LST products, as provided by the ground segment, are available via Terrascope, the entire archive. So this here is an example of the file name of Sentinel-3A SLSTR level 2 LST. It again has a start and end of the measurements, the timestamp of the processing, and then some, this is the duration of the segment. So it's important to know that this data is unprojected data. So it's on the 1 kilometer measurement grid. As you see here, this is Gibraltar. It's unprojected data. It's 3 minute frames. That's these 180 seconds duration of the segment. The product contains a large number of bands. The most important ones is this LST band in Kelvin that I displayed here. There is also an uncertainty band. There is a series of bands that indicate the different components of this uncertainty. So there is a random component, a systematic component, and then also the specifics components related to the atmosphere, components related to geolocation, and so on. There is also an exception flag. There are some annotation layers, and so on. So these products are also provided in non-time critical modes. So it means should be within 1 month after acquisition, but in practice within 3 days. And it's a day and night product. So also nighttime acquisitions are available. On product quality, same story. So it's a continuous evolution. The most important updates in the LST processing, I've listed them here. So in February 2019, they updated the retrieval coefficients to improve the variation across track. In January 2020, they revised the ortho-regridding, improved the quality checks, improved the flagging of clouds, and so on. In May 2020, this is an important one, they redid the product distribution. So from then onwards, products are distributed as 3-minute tiles. Before, it were pole-to-pole orbit files, and that's still the case in the archive we have on Terrascope. So for Sentinel-3A, it's still pole-to-pole orbit files before this date. At that time, they did the reprocessing for Sentinel-3B. So for Sentinel-3B, it's 3-minute segments over the entire archive. From June 21, the product includes the per pixel uncertainties, and they also improved the snow masking. And in February 22, they improved the cloud masking. So same story here. The opt-MPC does routinous validation of these products and also performs or provides information to users every time a new release is done. So these product notices, data quality reports, and annual performance reports are available in the document library online. So just one slide on the LST product quality, what is done in the opt-MPC by the University of Leicester. So they compare the satellite retrieved LST in the y-axis with in situ measurements from radiometer sites for a large number of, well, a considerably large number of stations. This is just one example for Table Mountain for 23. So on the left for Sentinel-3A, on the right for Sentinel-3B, the matchups are split into nighttime observations in blue and daytime observations in red. What you see is a slight overestimation of the higher temperatures and negative errors or negative bias for the nighttime observations, but a very good agreement in general. So next section is on product access. Let's see. One of the first points of access would be the Terrascope viewer. It can be used for product exploration. You can visualize, for example, the Sentinel-3 VG1 and V10 products. You can also use some tools to compare products and also download products. For product download, you can use the Terra catalog. So there is the OpenSearch API and a Stack API, and you can use those responses for downloading products. You need authentication, so you need a Terrascope login. So the Terrascope Python client allows you to integrate these OpenSearch APIs in a Python application, and it allows you to download products that you find that way. Of course, in these modern times, you don't need to download all products. There are other options, for example, using a Terrascope virtual machine, as I will show later, or you can access data via OpenEO, and then you don't need to download data. So OpenEO allows you also to download data, but also to do advanced analysis and to integrate in your GIS environment or in an application without downloading data. So OpenEO has an API that allows you to connect to the Earth observation product providers, let's say in a simple way. So the capabilities of OpenEO, you have a Jupyter Lab where you can have a Python notebook and you can access data directly. There is also a web editor, which is a GUI where you can interact with the OpenEO API and you can perform a number of basic tasks for data processing. And then there is the EO Plaza, which is a self-service portal, let's say. You can publish your algorithm there, or you can use algorithms that are published by others. What are the Sentinel-3 products on OpenEO? On Terrascope, connecting OpenEO to Terrascope, you have the ALSI level 1B and the SLSTR level 1Bs, and the SYN VGT 1 and 1 daily and 10 daily composite products. Then you can also use OpenEO to connect to the Copernicus data space ecosystem, which is the overall point of access for Sentinel data. There you have the ALSI level 1B products, SLSTR level 1Bs, the land surface temperatures, and the SYN level 2 products. Upcoming are there the VG1 and V10 products. So as an example on how to access Sentinel-3 products using OpenEO, first you load the OpenEO library, you authenticate for access, you load a collection, and you download the data. This is here a short example on how to use the OpenEO web editor for downloading specific bands. That's what you do here. Here you select a specific band. You can select a specific region, a specific time frame, and then you run it, you launch it, and you download these data. This is an example of how you can use OpenEO for more specific or user-defined processing. So again, you authenticate, you load a collection. Here, Sentinel-2 level 2A products and the SLSTR level 2 land surface temperatures. You do some calculations. You convert, for example, to degrees Celsius. You aggregate to weekly means, and you resample to the Sentinel-2 grids, and then you can download the outcomes as an example. Another way to access and explore data without downloading is to access the data that is available on the virtual machines of Terrascope. So you can apply for a virtual machine on terrascope.be. It comes with a series of applications such as the ESA Snap Toolbox, QGIS, GDAL, Python, and so on. And you can use it to do advanced analysis or to do prototyping of your application. Then the last section, what's next? Sentinel-3 is being prepared for launch. It will be launched in 2025 from French Guiana. Let's hope. After launch of Sentinel-3, they plan again a tandem phase. So what they foresee now is that first Sentinel-3 will fly in tandem with Sentinel-3B, and then it will move to the orbit of Sentinel-3A to fly in tandem for some months with A, so C and A together. And then they will move Sentinel-3A to a storage location, so it can be relocated in case of failure of the B or C satellites. And then in 2028, there will be the launch of Sentinel-3D. At least it's planned. After that, so after C and D, there is the next generation. So it's called the next generation optical because the topography sensors will be on a separate platform. So the next generation optical will be the follow-on on Sentinel-3 ALSI and SLSTR to continue the operational data stream. They also plan an enhanced continuity. So user needs, of course, are also evolving. So for example, the advanced ALSI, as they call it, the ALSI, will provide an increased number of spectral bands, more than the 21 we have now, and an increased spatial resolution. So the detailed mission requirements are still being consolidated. But one thing that is would be interesting to know from you is how important it is to have the long-term continuity of the SYN VGT products. Should we still foresee to do that in the next generation? So I would just like to say, if you foresee a need for this long-term data records for your application or service, mail me, so at least I know who is interested in this long-term continuity. Then on the shorter term, what we plan in Terrascope is to provide global land surface temperature composite products. So we will start from the level 2 LST as we have them now, but we will do a projection to a fixed grid, and we will do compositing, temporal compositing, to provide daily land surface temperature composites and 10 daily land surface temperature composites. So it's planned to also include it in the Terrascope catalog and the viewer for users to have access to this data in a quick way. So this is the last poll. The question is, are you interested in global land surface temperature composite products? And if so, would you like them on a regular grid? So for now, in our prototype, we foresee a regular lat-long grid similar to the ones from SYN VGT or the PROBA-V and SPOT-VGT archives. And we foresee the same daily and 10 daily time period for temporal compositing. So I see some interest, that's nice. And especially in and I see that the regular grid is fine, and the daily and 10 daily synthesis products, it seems fine. Okay, that's good to know. We can continue with that evolution. Okay, we have reached the end of the webinar. I have no idea how much time it took me. So we have discussed the background of the Sentinel-3 mission. We've touched more details on the SYN VGT and land surface temperature products. I've briefly shown options on how to access these products, and we've seen a glimpse of what is planned for the future. So I want to thank you for your attention and for your feedback. And Jürgen, I think there's still time for some questions.
Yes, thank you. Thank you, Carolien. It was a very interesting and very comprehensive presentation. I currently have one question concerning LST. Is there also an issue in terms of temporal consistency with all these updates, or is there a reprocessing underway?
I don't think there is a level 2 SLSTR reprocessing planned for the moment. I think the issues in terms of temporal consistency are less than, for example, for the SYN VGT products. But what we, for example, foresee in the compositing is a propagation of the per pixel uncertainties. Of course, before a specific date, these are just not available. So we won't provide them in the composites either. But it's still to be seen, the reprocessing. Let's hope.
Yeah, it's a bit strange that all these product updates don't get integrated in the full archive. Is there any rationale for that?
It's mainly, according to, at least as far as I know, a budget issue. So especially for the SYN VGT products, for example, you would have to reprocess also the level 1s from both ALSI and SLSTR before you start reprocessing the SYN VGT or the other SYN products. So it's a matter of budget, and it's I hope in the next generation we will have more strict requirements on this.
Okay.
It should be foreseen more regularly. I agree. From a user perspective, it's
a bit
needed.
strange.
Yeah.
Okay, while we are waiting for other questions, I have one. You were talking about these LSD composites. When can we expect them to be available?
Well, there is a prototype processing scheme ready, and we've tested it. We are currently evaluating a sample that we have processed. The next step is to include it, to implement it in the operational processing. So depending on the issues we encounter, it goes quicker or more slow. But I expect the first products to be available after summer. And if someone is interested to be a beta user of these products, you can contact me. So we can try to provide early access to the first products and see if we can get feedback from users. That would be very nice.
Yes. It's been very clear because I don't get any other questions coming in. But on the other hand, it's close to 5, so I propose that we close the question Q&A right now. But let me first, before we close totally, let me remind you that we have other webinars coming up in, what is it? 14 days. No, it's on a Thursday. We will have a webinar on World Cereal, which is a very interesting product, global seasonal crop mapping, which is going to be discussed by Isa and our colleagues at Vito. And then in April, we'll have a webinar on air quality monitoring on the additional Sentinel-3 5P data products that were integrated in the past year. So with that, I would like to thank Carolien again for the clear explanation. What I want to thank all of the attendees for being patient and staying around. So it shows that the explanation was interesting. And I hope to see you again in 2 weeks' time.
Okay, thank you.
Thank you.
Bye-bye.